Now, that is our neutral point. Those are our neutral connection on the rail. Note that these are neutral points which are connected on the rails. The railway line is the neutral point, the return. That is our fast moving train or locomotive. As you see how it is very fast. Now let's dip into the connections. Yes, in the train, electric trains, they uses electricity. Which electricity? Those are our overhead. We are going to talk about the overheads, and those are the poles holding the overhead and the rails down there. Overhead is only one single power line, which is called, technically it's called a single overhead line, which is connected to the train. It carries 25 kVA or 25 kilovolts. Note, it carries 25,000 volts, very high voltage on those overheads which you see. Okay, now these overheads, there is a component or a device which is called a pantograph. A pantograph is the one which connects those overhead with the train. The train head, it is the connector between the overhead line, which is carrying the power, with the train. Okay, now these trains, they have a transformer inside them. When they get power from those overhead line, it is a single line with high voltage of 25,000 volts. It has a transformer. Before a transformer, there are circuit breakers, and these circuit breakers are used to disconnect or connect the power line when in case there is a short circuit or a maintenance work or a repair on the train is happening on those overhead which you are seeing there. This power line above the train is connected to the transformer inside the train. Okay, those are our neutral points, because on the overhead we don't have a neutral point because of the high voltage on the above, and this neutral is connected direct to the rails. As you see, that cable, that black cable which moves to the rail, is connected direct to the rail, as you can see there. I think you can see. Some people, they don't know how, if there is a neutral line, and that is how the train is moving. It starts slowly and goes. The more it goes, the faster it comes. Okay. Now, on the transformer inside the train, or on top of the train, there is a transformer line, and this transformer is used to distribute. That is our overhead line. This transformer is used to distribute power in different circuits in the train. As you know, there is the lights, there is an inverter, there is a fan, there is a heater. Now this transformer helps to distribute those powers. Okay, let's go more. The power from the transformer, it is taken to the rectifiers. These rectifiers, people who know electronics, rectifiers are something like diodes, which change or converts AC into DC. AC is alternative current which comes, and if we pass it through a rectifier, that is our fast, that is how it moves. When it has taken long on the rail, its speed changes. This converter converts AC into DC power, and this power is again sent to an inverter, which inverter will convert again DC into AC power. Okay, the reason why the power is converted from AC to DC is because we need a stable power supply from the inverter. The inverter carries a stable power supply, as you know. Okay, when power is not stable, the train can't move well. Also, it has these motors, the three-phase motors, which uses a stable three-phase power from an inverter. The inverter receives a single phase power, then it changes it into a 3-phase AC power from a DC phase to 3-phase AC, which will be connected to the 3-phase motors. Don't forget that these rails are connected to the motors, the AC motors, to rotate the wheels whenever the power is transferred to AC motors, and the train will start moving. Yeah, and that's how the train works. Now the lights inside the train, there is an inverter which converts that DC power into AC to give the lights, the lights which you see in the AC, I mean the train, the fan, the heaters. Now there is an inverter which supplies that backup, and that's the way. Now this power goes to the motor, and the motor is connected to the wheels. This motor changes the power supply or electrical energy into mechanical energy, which mechanical energy makes the wheel to move mechanically on the rail. And these rails and these motors which are connected in the rails, I mean in the wheels, the motor makes the wheels to move mechanically. That's why we say a motor which is connected to the wheels on the train, it receives power and it converts this power from electrical energy into mechanical energy, which changes the wheels, which will make the wheels to move. You get my point? Make the wheels to move and the train will start moving. Not this, that a neutral, these rails where the wheels are moving, they are connected to the neutral. That is the neutral line for the train. That's why they don't allow people to move from the rail lines, those electrical rail lines, because they are connected on the neutral line. Those are their neutral lines. The train has no neutral. It only uses live wire, power line. After converting everything, the motor converts electrical into mechanical. Then these motors are connected to the rail. And the rail, they are made of steel, whereby this steel is a good conductor of electricity. And these steels are the one which are called the return. The rail line is the return line or the neutral line. If you're an electrician, you'll call it a neutral line. But if you're an electronic technician, you may call it, or a solar technician, you may call it ground. Those are technical names, right? Ground or neutral. The neutral line for the train is the rail line. That's why they don't allow people to use or to jump into the rail line. You may be shocked. Yeah, and that is how the railway moves using electricity. It can't move without that overhead line, which carries 25,000 volts. That is high voltage. Then it's neutral. It is the railway. Yeah, the cables from the source of the power is connected to the railway line. The neutral part, it is both neutral and earthed, because the rail line is on the earth, meaning it is earthed. Then the overhead line, which is only a single line like this, a single power line, it is the one which passes up and it supplies the train. And that's the principle of the train, how the train uses electricity to move. Let me talk about when it breaks. To get a brake, the one driving the train, he controls the train the way you see it. He controls the train. He stops the power which is coming from the transformer or from the overhead. Okay? Then the inverter here there is some batteries in the train which store power, and this power is connected. These batteries are connected into an inverter, whereby an inverter will convert the DC power from the battery into AC power, that is alternative current, which will again be connected inverse to the wheels. Remember, we said the wheels have the motors, the three-phase motors. Now, when the wheels were supplied with power and they are running clockwise, the moment he stops the power from the overhead, then he connects the inverter. The inverter will connect automatic and power will come from another side, which is the inverse electrically. And the power will force the motor to turn the inverse direction. Remember, it was moving forward. Now it's going to move backward. The motor, that is the rotor. The moment the rotor is rotating in an inverse direction, the train will be stopping. It's like, for example, if someone is running very fast, going in front, running in the speed, and they tell you, come back instantly, you will first reduce on the speed and you come back. Then you reduce the speed, then you stop, then you come back. And that's the principle how the train moves. Thank you so much. And thank you for listening. See you in the next episode. You only find this project only on physics mindset only.